Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P1684 indicates a throttle valve return spring performance issue in the Honda Odyssey, model years 2011 through 2017. This error relates to the throttle valve mechanism that regulates airflow into the engine, impacting engine performance and responsiveness. The throttle valve is mounted on the throttle body, located between the air intake and the engine's intake manifold. When the throttle valve is functioning correctly, it opens and closes in response to the accelerator pedal position, ensuring optimal air intake. However, if the return spring malfunctions, it can cause the throttle valve to stick or be sluggish in its response. This can lead to poor engine performance, increased emissions, and potentially safety concerns if the vehicle does not respond appropriately to accelerator input. It is critical to address this issue promptly to ensure safe and efficient vehicle operation. The DTC P1684 signifies a specific performance malfunction related to the throttle valve return spring. This spring is responsible for ensuring that the throttle valve in the throttle body returns to its closed position when not engaged. The throttle body itself is typically located towards the front of the engine bay, between the air filter and the intake manifold. It contains a butterfly valve that adjusts the airflow into the engine, which is critical for proper engine functioning. If the throttle valve does not return as intended, it can cause an irregular air-fuel mixture, leading to inefficient engine performance and increased emissions. Understanding the function of the throttle body and the return spring is essential for diagnosing and rectifying this issue, ensuring that the vehicle's engine management system operates smoothly for optimal performance. Several potential causes could result in the DTC P1684 being triggered. First, the throttle return spring itself may be faulty, either due to wear and tear or damage, preventing it from functioning correctly. Second, any obstruction within the throttle body that restricts the full closing of the valve can lead to this error. Additionally, wiring issues such as frayed wires or poor connections between the throttle body and the powertrain control module, PCM, could contribute to this malfunction. Finally, environmental factors like dirt or debris may also impact the throttle body's performance. Each of these causes should be thoroughly investigated during diagnosis, ensuring that the root of the problem is accurately identified and resolved. The presence of DTC P1684 can present various symptoms that a driver may experience while operating the vehicle. One of the most common symptoms is diminished engine performance. Drivers may notice a lack of power during acceleration. Moreover, increased emissions may also be a consequence, as the incorrect air-fuel mixture results in higher levels of pollutants being expelled. Throttle response issues can be notable. For instance, the vehicle may hesitate or lag when the accelerator pedal is pressed. Additionally, the steering wheel may experience unexpected vibrations due to inconsistent throttle operation. These symptoms are crucial indicators that something is amiss within the throttle control system, warranting immediate attention and diagnosis from a qualified technician. The first step in troubleshooting DTC P1684 requires the ignition switch to be turned to the on-to position. This action engages the vehicle's electrical system, allowing access to onboard diagnostics. Before proceeding, it is essential to ensure safety by avoiding any contact with the throttle body during this process, as the throttle valve can activate unexpectedly and cause injury. Recording all freeze data and reviewing any existing onboard snapshots is also vital for understanding the context in which the DTC was triggered. This collected data will help identify potential trends or issues present before the fault occurred. By starting with the ignition in the on position, technicians can gather necessary diagnostic information to ascertain the nature of the throttle valve return spring performance problem. The second step involves clearing the stored DTC using the Honda Diagnostics System, HDS, a specialized tool used for Honda vehicles. This step resets the vehicle's diagnostic system, preparing it for new fault tests. Clearing the DTC allows technicians to determine if the problem is persistent or intermittent. After clearing the code, it's important to reinitialize and perform a check to see if the DTC reappears after subsequent tests. The HDS provides critical diagnostic information that aids in understanding any other potential fault codes present in the system, allowing for more comprehensive troubleshooting. Ensuring a clean slate for diagnostic testing is crucial for accurate resolution of the issue at hand. In the third step, technicians must start the engine and maintain a constant speed of 3,000 RPM without any load, either in park or neutral. This controlled condition allows the system to operate under specific parameters, promoting accurate monitoring of throttle valve behavior. Continuing this for a duration sufficient for the radiator fan to activate ensures that the engine reaches normal operating conditions. Observing how the throttle responds during this phase can provide insights into whether the return spring and throttle valve are functioning correctly. If the throttle functions promptly and as expected, it supports that the parts involved are operating as intended. Conversely, any irregularities should be documented, as they may indicate a deeper issue with the throttle return spring's performance. The fourth step requires turning the ignition switch to the lock 0 position and allowing a 10-second wait. This pause is necessary to reset various electronic systems within the vehicle. By powering down the electrical systems, technicians can ensure that any changes or errors caused during earlier testing are cleared. Allowing this short period also provides the engine control mechanisms time to stabilize. Preparing for the next action is crucial. This waiting period is not designed for troubleshooting, but rather as a transition to subsequent diagnostic steps. Properly following this procedure will facilitate a more accurate evaluation in the upcoming diagnostic checks, ensuring that the repair process can proceed smoothly. Step 5 involves turning the ignition switch back to the on 2 position to access the system's diagnostic capabilities once again. This allows technicians to check for pending or confirmed DTCs using the Honda Diagnostic System, HDS. It is essential to observe if DTC P1684 reappears, or if other codes are indicated, as this could give further insights into systemic issues that may be affecting the throttle mechanism. The HDS will provide real-time information and logging capabilities to evaluate the performance of various components connected to the throttle control system. Properly interpreting these codes is vital for determining whether the issue persists or if it was merely an intermittent failure during earlier tests. Documenting these findings will assist technicians in resolving the root cause effectively. During this step, technicians need to ascertain whether the DTC P1684 is present again after performing the previous troubleshooting steps. If the code is indicated, the process moves on to Step 7, focusing on physical inspection and mechanical checks. Conversely, if no DTC is present, this may point to an intermittent failure, suggesting that the throttle system is functioning correctly at this moment. In such cases, it becomes crucial to investigate further for any loose or poorly connected terminals at both the throttle body and the powertrain control module, PCM. Accurate diagnosis may require performing tests again after reconnecting any identified weak connections. Each decision in this phase is significant, as establishing the presence or absence of the DTC P1684 will guide further actions in maintaining the vehicle's proper function. The seventh troubleshooting step requires turning the ignition switch to the lock 0 position once again. This action will power down the vehicle's entire electrical system, allowing technicians to safely proceed with the next physical inspection and repairs, as it is crucial to ensure electrical components remain undisturbed during disconnections. Shutting off the ignition minimizes safety risks and prevents unintended activation of certain systems. After powering down, technicians should prepare for disconnecting the necessary components, emphasizing careful handling, especially around sensitive areas like the throttle body. Following these precautions is essential to overall vehicle repair safety, further ensuring that technicians can inspect or replace parts without inadvertently causing harm or further complications within the vehicle's systems. In the eighth step, disconnecting the intake air duct from the throttle body is necessary to provide access for inspection and maintenance. This duct is responsible for channeling air into the engine's combustion chamber, and removing it allows for an unobstructed view of the throttle valve and surrounding components. Once the duct is removed, technicians can closely examine the throttle body for any visible issues, such as obstructions, wear, or misalignment. This inspection is critical, as it helps identify mechanical problems potentially contributing to the P1684 DTC. Additionally, ensuring that the throttle body is clean and free of debris is essential for optimal engine performance. Hence, a thorough examination during this step will facilitate effective repairs in subsequent actions. The ninth troubleshooting step involves physically pushing the throttle valve open to assess the return spring's functionality. Technicians should do this carefully to prevent unintentional activation of the throttle mechanism. This step allows direct observation of how well the throttle valve operates when engaged manually. By witnessing the spring's response during this test, mechanics can evaluate whether it is functioning adequately or exhibiting performance issues. A proper return spring should allow the throttle valve to close promptly and smoothly when released. Any sticking or resistance signals potential problems requiring further examination or replacement. Visually inspecting the throttle valve for damage or wear during this step is also essential, as this may reveal underlying issues contributing to the P1684 DTC. The final troubleshooting step involves carefully releasing the throttle valve after being manually pushed open to see how the return spring responds. Observing the throttle's behavior during this release is necessary to determine whether the return spring properly re-engages the valve to its closed position. A responsive spring should allow the throttle to return quickly and without hesitation. If delays occur or the valve remains partially open, it indicates likely failure or malfunction of the return spring, which will need to be addressed. This observation of the spring's capabilities can be critical in diagnosing the root cause of the performance problem indicated by the DTC P1684. Carefully noting the throttle's behavior at this stage provides key insights into whether further adjustments, repairs, or part replacements are required to restore proper function. Upon completing the necessary repairs or adjustments associated with DTC P1684, performing a final verification is crucial before considering the vehicle fit for use. A comprehensive test drive should be conducted to confirm that the throttle response has returned to normal functionality and that there are no lingering DTCs present within the system. During this test drive, technicians should closely monitor the throttle's performance across various driving conditions to ensure consistent operation. If the system demonstrates proper response, including smooth acceleration and no signs of hesitation, it can be concluded that the issue has been effectively resolved. Documenting the successful completion of these tests is vital for maintaining accurate service records and ensures confidence in the vehicle's safe operation henceforth. Preventive maintenance plays a critical role in averting potential issues associated with the throttle system, such as DTC P1684. Regular inspections of the throttle body and return spring assembly can help identify wear or damage before it leads to performance problems. Keeping the throttle body clean of carbon buildup and debris is essential for smooth operation, directly impacting the air-fuel mixture and the engine's efficiency. Technicians should also periodically check all electrical connections associated with the throttle body and the powertrain control module, PCM, to ensure there are no loose or corroded terminals that may influence overall performance. By implementing these preventive measures, owners can enjoy a well-functioning vehicle and minimize the likelihood of encountering similar issues in the future. In conclusion, DTC P1684 signifies a throttle valve return spring performance problem, a crucial issue affecting engine performance in the Honda Odyssey from 2011 to 2017. Through diligent troubleshooting steps, including observations of throttle behavior, inspections, and connections, technicians can identify and rectify the specific cause of the problem. It is vital to accurately follow each step in the diagnostic process to ensure proper vehicle operation and reliability. Furthermore, incorporating preventive maintenance practices can help mitigate future occurrences of similar DTCs, prolonging vehicle life and function. Overall, addressing this issue expediently not only upholds engine efficiency, but ensures the safety and satisfaction of the vehicle owner. Please like and subscribe to the channel. See you next time.